He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
You wouldn't want to have an arachnophobe on the team.
No. Everyone on the team likes spiders. There's been a few visitors who aren't spider fans, and there's some quite interesting reactions when we lift up the covers and show off these big female spiders with the big red stripe on their back. Yeah, there's some great priceless facial expressions and almost whole body reactions where people just, give a bit of a shiver.
Kia ora, nau mai haere mai ki te ao horihanga, ko Ellen Rikers tēnei. Hello and welcome to Our Changing World. Aotearoa is known for not really having any dangerous creatures. We don't have snakes, apart from the odd sea snake, and we have just one native spider with a potentially venomous bite, the katipo. But we do have one venomous Australian import, the redback spider. It found its way to New Zealand in the 1980s, and it's a dangerously venomous species, part of the widow family of spiders. Their name comes from the striking red stripe that features on the female's hourglass body. Redbacks are found in central Otago and New Plymouth, and here, inside this plant and food research lab, just outside Ōtautahi, Christchurch.
We currently have about 800 redback spiders in this lab.
I'm here with Dr. Andrew Twidle, a scientist here at Plant and Food Research. He's leading a group trying to find environmentally friendly ways to control invertebrate pests, that is, animals without a backbone, like insects and spiders. They want tools that are super specific, instead of the broad spectrum pesticides that sometimes also kill the organisms we do want to keep around. That's why he has 800 redback spiders. He's trying to find a way to control this unwanted pest and stop their spread without affecting our native insects and spiders. We'll come back to this goal later. But first, let's meet the 800 spiders.
It's probably a good time to actually show you some of the spiders. So
okay.
What we've got here is they're all in their own individual house, so we have them all separated out, and then we have them in one extra big box as well, so they're doubly contained. So, because at the moment they aren't in Canterbury, and obviously, we believe they aren't in Canterbury, and we don't want them to escape, so we keep them all, as you can see, labelled here with numbers.
Right.
And
so it's like a big plastic box, and then inside there are a bunch of plastic jars, which are kind of like spider apartments.
Yeah, effectively, a wee spider motel, if you like. And you can see inside each plastic box here we have an X cross made out of bamboo sticks just to support their web structure. And you can see, if you look against that black background there, you can see the wee lines coming down onto the ground. So they have little trip wires there to catch their prey. And you can see the bottom's littered here with a lot of dead beetles that these spiders have been eating.
And so that's a female in there?
Yes. So there's quite a difference between the male and female of the spider species. So the females, as you can see here, are a little bit smaller than this is a bit of a small one, but their abdomen's a wee bit smaller than my thumbnail, and then their big legs protrude out. And the males, on the other hand, are tiny, so they're about the size of a pinhead, their abdomen. So I'll just show you one of those as a comparison so you can see there. So obviously males and females housed in big separate boxes, but
so the male's just in kind of like almost like a film canister.
A little film canister sized house, and because you can see how tiny he is there.
Oh my God.
So if you look at him beside the female there.
Wow, that is quite a size difference.
Yeah, it's huge. They're probably about.
It has me wondering about the mechanics of that.
Yeah, so it's not good to be a redback male. For when they mate, they actually get eaten by the female. So they're one of the only few species in the world that do this. So they sacrifice themselves to the females because it's thought that perhaps where they evolved in South Australia was pretty desolate environment, and the male offered themselves as a meal effectively to sustain the female while she's
talk about chivalry.
rearing the babies. And it also, there's a bit of a dual purpose there as well, probably because it allows him to mate with her longer, so he can transfer more sperm and effectively, guarantee more of his
Right,
offspring.
he'll
so
be the
it's
dad,
it's an advantage for him.
The spiders here in the lab were collected from Central Otago in late 2023. Spider expert Cor Vink from Lincoln University had scoped out some good spider spots, and a team scooped up 60 adult spiders, plus a whole bunch of egg sacs that have since hatched into hundreds of spiderlings. Looking after all 800 of these spiders is a massive job. It takes 3 people all chipping in to keep the spiders happy and healthy, including insect scientist Tom Sullivan.
I'm Tom Sullivan. I'm an entomologist here at Planet Food, and I'm working on spiders now too. So
Tom has to manually feed every individual spider once a week, hand delivering their meal direct to their spider apartment. And so what have you got here?
that is, I'd say about a 3rd instar baby spider. Male or female, don't know. Can't tell until they get a little bit bigger.
It's what about the size of like a chia seed?
I'm not sure how big a chia seed is, but
A poppy seed?
Yep.
A little bit bigger than a poppy seed?
yep,
Yeah.
sesame seed, poppy seed. The legs are bigger, of course, but the
Yeah.
body's quite small.
For a spider the size of a poppy seed, you only need a teeny snack. The bigger spiders get beetles or even crickets. But here, Tom has a vial of fruit flies. And these are specially bred so they are flightless, so they don't get heaps of little flies buzzing around the lab.
Yeah, these are the flies that don't fly, so you can see they just all line up on the rim of the container, and we just get the tweezers.
Tom
and
plucks out a fly with a pair of tweezers and drops it into the spider jar.
drop it in.
So he'll just find that, or
Yeah.
he or she will find that and have a snack.
Yeah.
Easy, except you're doing it 800 times.
Yeah. And every time I do it, I have to find the spider and make sure it's alive and healthy, check if it's a male or a female, and then, open the jar, keep an eye on the spider, feed it a fly, and make sure it's still in there when I close the lid. Yeah.
They do seem quite docile.
They are until they're not. They can really run fast when they want to. Typically, they love to be on their web and they don't want to go off it. But if you disturb them enough, they will. And if they're off their web, then they run like crazy. So
Haven't had any mishaps?
Nope.
That's good. And you're wearing some gloves there as well.
yeah, we don't think these little ones can bite us, but we're not going to take any chances in it all the same.
You really, really don't want to get bitten by a redback spider. They're one of the most venomous spiders in the world. Here's Andrew again.
They're a real risk to human health, which is why Tom's wearing all the protectives there. So long sleeves with cuffs and then gloves coming over those cuffs. So he can't be bitten through those. And we have thicker gloves that we actually wear with the adults. We have had them biting the gloves, like the adult females. So they can be aggressive, yeah. So
Wow, that must be quite disconcerting.
yeah,
scary.
it is, but it's good to know that the gloves do stop the bites. So
True. Redback spider venom includes a neurotoxin called alpha-lactotoxin, and it targets animals with a backbone, or vertebrates, and that includes us, humans. Apparently, this is quite unusual for spiders.
most spiders' venom only targets other invertebrates, so animals without a backbone, so that's insects and spiders. But because of their really strong silk and probably their sort of harsh habitat that they evolved in, they've developed to catch pretty much anything that comes along. So that can be lizards, mice, even snakes they can catch and kill in their webs. So because of their silk so strong, it's one of the strongest spider silks known, so it's stronger than steel by weight.
When a redback catches prey in its web, it wraps the prey up in sticky silk and then injects venom to liquefy its insides. It then sucks out the gooey guts. In humans, a bite can cause severe pain, vomiting and sweating, nasty stuff, but not life-threatening, especially with anti-venom available nowadays. In Australia, a few thousand people are bitten by redback spiders every year, but not all bites result in venom actually being injected.
Most of the time when they bite us, it's self-defense. So they use their venom obviously to kill their prey. So they're not looking to do that when it's a defense response.
In Australia, only about 250 bites every year involve that injection of venom. Plus, it's mostly the larger females who bite. Those little males, they're just too small. Still, these spiders do pose a risk. Some vineyard workers in central Otago have been bitten by redbacks, and hospitals across Aotearoa do now stock redback antivenom. But it's not only humans threatened by these spiders.
Outside of people, they also threaten a lot of the native fauna of New Zealand, so that includes a Cromwell chafer, so there's only 3,000 of those beetles left. And they have their own nature reserve, but that's been invaded by the redbacks and now requires DOC to manually patrol the reserve, manually by hand removing spiders and webs, so that's pretty laborious task. But if they didn't do that, they'd be extinct. They threaten native skinks. They capitally catch New Zealand skinks and geckos in their webs.
Those Cromwell chafer beetles in particular, they're a worry. They're small brown beetles that bumble around a single paddock near Cromwell, about 81 hectares in size. They're found here in central Otago and nowhere else on Earth, and they're also critically endangered. So when the redbacks eventually found their way into this patch of grass, the beetles were in even more trouble.
Sometime in the 2000s, they invaded the chafer reserve, and a student from Otago University was doing a project there, and she found in 2012, 2013, redback webs in the chafer reserve, and they had like as many as 10 beetles per web. So she found that over that season they'd killed hundreds of chafers just in that one summer. So since then, DOC's been really great. They've been out, as I said, patrolling the reserve and just squishing spiders and webs as they find them, but it's like looking for a needle in a haystack, and because they're all round the reserve, they just keep coming in as well.
The redbacks also pose a threat to our native katipo spiders, which, like the Cromwell chafer beetle, are also in trouble.
Redback males can mate with katipo females, but it doesn't go the other way because the katipo males are quite a lot bigger than the redback males. So when a redback male comes up to a katipo web, the katipo thinks, oh, this is he's a bit of a runt, this boy, but he'll still do the job. But the difference is when a katipo boy comes up to a redback web, he's quite a bit bigger than the redback male, and the female doesn't see him as a mate, she just sees him as prey, so she won't be receptive to his courting, she'll just kill him.
This type of interbreeding, if it were to really take off, could lead to the extinction of the katipo and produce a hybrid redback with greater ability to spread. So all of these threats to humans and to our endangered species mean it would probably be a good idea to figure out how we can get rid of these Aussie invaders, or at least control their numbers, especially while we have just 2 isolated populations.
Just to compare that, they came into Japan in the 1990s.
The Australian redback spider was a new and unwelcome visitor to Japan this year. It's believed the deadly invaders originally hitched a ride on a container ship, and now with electrically warmed toilet seats in almost every home.
The redback spiders have well and truly moved in. They're now found in 45 out of Japan's 47 provinces. Here in New Zealand, we're lucky they haven't spread any further. It would be very easy for someone to inadvertently shift a pellet with a sneaky stowaway female redback and her eggs right across the country, seeding a new population somewhere.
It's only a matter of time before they do spread, and I think that's why this is such a timely project. We're developing a tool that can be used to first monitor where these spiders are, because at the moment we don't have any way of doing that. And then B, give us a tool that can be used to specifically target them in any environment without harm to other organisms.
Andrew and a team of spider and insect experts have come up with a cunning idea to trap male redback spiders. They're making spiderweb perfume, laced with the smell of female silk that is irresistible to male redbacks.
It's the virgin silk that's attractive to the males. So the mated females aren't attractive to the boys, but the virgin ones are. And so what we've been doing is collecting lots and lots of that virgin silk so we can analyse the compounds coming off that. So effectively the odours coming off it, which the males are then attracted to. and we can see a really clear signal from that virgin silk that the boys really like and head to.
This spiderweb perfume will act as a lure, attracting male redback spiders from far and wide to a trap. This concept of a smell-based trap has been used a lot for controlling insects, but this is the first time anyone has tried to make a smelly spider trap. But before they can even make the trap, they need to know what those alluring spider smells are. And for that, you need virgin spider silk. Lots of it.
So this is the spider silk here, and so you can see this is a 4ml vial, so about half the size of my little finger, and it's half filled with spider silk, so that's 10 webs worth piled in there.
Wow.
And then we collect this little the little aerial headspace up above the silk there, and then we can analyse that in the chemistry laboratory to get an idea of what the compounds are.
But when you're dealing with little critters, identifying those smelly compounds is a bit tricky.
My experience previous to this has been identifying insect pheromones, and the thing about insects and spiders is that they're really small organisms, so anything that they produce is going to be in tiny amounts. Because typically for natural product chemistry, to identify any compound, we'll use NMR, which is nuclear magnetic resonance. And that sounds a bit of a mouthful, but it's an amazing tool. And it pretty much, you put in a small amount of the compound into this instrument and it'll give you the spatial arrangement of atoms in that compound. So you can pretty much, gives you what the structure of that compound is. The insects and spiders, unfortunately, produce very low levels of those compounds, well below the detection threshold of that instrument. So we have to use other techniques which are capable of doing it, but they require a bit more input from us and detective work, really. So it's an exciting project from that aspect for me as a chemist.
The other exciting part is that very few spider signalling chemicals, or pheromones, have been identified. While thousands have been found for insects, just 15 spider pheromones are known. So far, Andrew and his team have detected 5 chemical compounds wafting off the virgin spider silk, and they've identified 3 of them. But they also need to figure out the ratio of these 5 components that make up the redback's signature scent. And then they need to make more of it in the lab.
I have full synthetic organic synthesis capabilities here, so we've got an artificial argon atmosphere, we have a vacuum line, and we can make up pretty much any compound that we can detect there in here. So
Right, so you can detect it and say, oh, this is what the spider is making in the spider silk, and now let's make a lot more of it.
Yeah, let's make a human-made batch instead of a spider-made batch. But sometimes those molecules can be quite challenging to make because no one's ever made them before.
Andrew is hopeful that the compounds should be fairly straightforward to make. If they're light enough to waft on the air, they shouldn't have too many atoms to assemble. But there will be other challenges.
What I do think will be the challenging part of this project will be getting the right airborne signature, because once we've got those compounds and made them, we then have to get them to release from a dispenser or release device in the same amounts that they're releasing from the spider's webs. So these compounds will all have different properties and different boiling points and all those things, yet we've got to get them to release out of our dispenser at just the same ratio as they're coming off the spider's web, so that can be quite a challenge.
To get that signature scent just right, they'll need to enlist the help of the male redback spiders.
We'll hopefully have lots of the boy spiders, and we can start testing them with what we call Y-tube bioassays. So that's where we have, I can show you actually a cylindrical glass tube. So we've got them in the oven here. So just think of a giant Y made out of glass, but it's hollow. So we'll have, sorry, this is just hot, so I'm just using gloves because we keep all these things oven baked, so it's not got no other odours present with it. So just imagine, as I said, this giant Y made out of glass and it's hollow. So in each arm of the Y, we have a different odour, and then they come into the central tube where the spider is. So then, and there's air blowing down each arm, so the spider's walking into the wind and down each arm's a different odour coming, and when the spider gets to the junction of the Y, it'll have a smell and see which smell it likes best.
This test with the Y-shaped tubes happens in the Spider Arena Lab. But don't picture the Colosseum just yet. On a lab bench, there's a mini tent set up, a sort of frame draped with blackout curtains to keep the arena dark, since the spiders are active at night. The Y-shaped tube sits inside the tent, and it's hooked up to tubes that dispense the two smells. And then there's a GoPro rigged above the tubes, angled to capture all the action. And there's also a red lamp, which lights the setup, since it's thought spiders can't see red. Each arm of the Y-shaped tube is about 20 centimetres long, and it takes the spider about 30 minutes or so to walk down it.
So we'll put them at the very bottom of the Y, and they'll have air blowing over them from those mixed arms. And to start with, they'll be shocked to go, oh, we've been moved out of our home into this Y, and they stand there, they'll be frozen, they'll be scared, no doubt. But then they'll perk up, they'll go, oh, I can smell something I like. And they start waving their little front legs around.
That leg waving, it's because that's how spiders smell, with these special sensory organs on their legs.
It's entertaining to watch. As I said, these spiders stand there swinging their front legs around, and they'll slowly move up the tube waving that, and then they come to the middle of the Y where the two branches come together, and you can see, but then they'll spend a bit of time waving their legs in each arm of it, and then they'll pick the arm they like and go up that one. So
Right, so you've done a little bit of testing.
we've done a little bit trying to just develop and get this method right, because obviously if you have the airflow too fast, they won't move. If you have too much odour, it overwhelms them. Yeah, so it's just getting all those conditions just right.
Once Andrew and the team have figured out the exact perfume that the redback boys really like, they'll head to the vineyards of Central Otago to test it out in the field. Remember, that's where the redbacks are quite common. This type of pheromone trapping, where the males get tricked into a trap by a tempting lady smell, is already a common tool for controlling horticultural insect pests. For example, they can be used in apple orchards, so we don't have to spray pesticide all over our produce to keep the bugs away.
But spiders, this hasn't really been done before, so using pheromones to trap a pest spider like this, so we don't really know how they're going to behave around the traps and getting the right trap structure, because if they smell something's not quite right, or suspect something's not quite right about the trap, they may not come in. They may come to it but then go, ooh, I don't like the look of this.
Tom, who we met earlier feeding the spiders, also has experience using 3D printers to make specialist traps. But how do you avoid catching all the other crawling critters that might wander past?
We don't want to accidentally catch other ground-dwelling insects. Like, eventually we'd like to get this out, obviously, in the Cromwell Chafer Reserve, where the endangered Cromwell Chafer beetles are. But we don't want to catch any of those precious beetles, so we need to have excluding factors for other things while maintaining an enticing entrance for the male spider.
Could you do that based on size?
Yes, that's one of the things we'll be aiming for, just because the spiders are, luckily for us, so small. It even work on similar species, because down the track, we'd like to expand this project, obviously, to look at trapping in the New Plymouth population as well. But there we'd have Katipo, so they probably would have similar pheromone components to the redback, so there would be a potential for cross-attraction.
The traps could be deployed to help us check we don't have any sneaky spiders hiding anywhere else around the motu.
It'll give us an idea of how far the population's spread, but it'll also give us an idea of the population density as well. So that could be quite a frightening find, I think, just because they are pretty cryptic. They hide really well in the wild. They hide underneath bushes, right in against the ground in the shrubbery. They hide under rocks. They live down rabbit burrows. If they were in this lab loose, they'd be up in the corners in the dark. You wouldn't even know that they were there. So I think they could be, more widespread than we perhaps think. But I think they haven't got to the main centres yet, because we'd be seeing people, accidentally getting bitten.
And it's not just detecting the presence of redback spiders that's possible. Because of the quirks of redback spider mating, A trap like this could have a real knockdown effect on spider numbers, even though it only targets the males.
They sort of handbrake themselves for this, and it's great because the females obviously eat the males. So if we have 99 out of the 100 males killed in our traps, that one male spider will go and mate with one female and she'll kill him, and that's it, he's done.
Andrew is optimistic that if the team can get the idea to work for redbacks, there might be a lucrative market for the technology in New Zealand, in Japan, and maybe even in the spider's homeland of Australia. Plus, the technology could be adapted for other venomous spiders in the widow family. But for now, the goal is to perfect the spider perfume and get it out into the vineyards of Central Otago.
We'll be hopefully putting out some traps there in the summer months. That's the aim once we can, as I said, but first we need those boys to emerge and give us, let us know what the perfume is, what that perfect signature mixture is.
Thank you to Dr. Andrew Tweidle and Tom Sullivan from Plant and Food Research. The project team also includes Nicola Sullivan, Dr. Cor Vink from Lincoln University, Dr. Tara Murray from the Department of Conservation, and Meikura Arahanga from Ngāi Tahu. This episode was produced by me, Ellen Rikers, with help from presenter and producer Claire Concannon and RNZ podcast producer Liz Garton. Sound engineering was by Phil Benge. Tēnā koe I whakarongo mai. Thanks so much for listening. Have a great week. Kia pai te wiki.